Hi there, I am Miss Page, and today I am going to be presenting a lesson on how to factor binomials completely. So, as when we learned how to factor trinomials, the very first thing we want to do is start by finding any greatest common factor, the GCF, and factor it out first. Then we are going to be learning about a special structure of a binomial that we call a difference of two squares. So we will have to look at the binomial we're trying to factor after our GCF and determine if it is a difference of two squares. If it is a difference of two squares, then it will factor actually into two binomials that are conjugates of one another. We talked about conjugates in the last unit, that they have the same first terms and their second terms are opposites. So a difference of two squares we can write in this structure. This is not the factored form. This is how we identify that we actually have a difference of two squares, if we can write it like this. And if we can write it like that, then the factors would have the structure of conjugate. So they both start with A from the first parentheses, and one would have a plus B and the other would have a minus B, which are opposites of each other. If then we've done that, then we want to make sure we write the complete product of factors that includes any greatest common factor from step one. We don't want to lose that. And also, we should check, just like we did with trinomials, to make sure that we have not made any mistakes. All right, let's take a look at this example. So you'll notice that your instructions say to factor each binomial completely, so as much as possible. But there's something new that's a little different here that we did not have with our trinomials. It says if the binomial cannot be factored, we are to write the word prime, meaning that it has only two factors, one and itself, just like a prime number. So that's a little different. We're not doing that with our trinomials, but we need to recognize when we have binomials that we cannot factor. So here we're looking at our 9x squared minus 16. So again, the first thing we want to do is look for a greatest common factor. So that greatest common factor can be a number, a variable power, or both. Here, since our second term of the minus 16 has no power of x with it, we don't have a power of x as part of the GCF. Our numbers are 9 and 16. Neither one of them is prime, but if we look at the 9, the factors of 9 other than 1 are 3 and 9. And we should realize that 3 and 9 are not factors of 16. So this is saying our GCF is 1. So since our GCF is 1, we are now going to move on to the second step, which is actually to examine this binomial, 9x squared minus 16, and see if it is a difference of two squares. So we have to check to see, can we write it in the structure, a quantity squared minus a quantity squared. And if we can, then it is. And if we can't, it isn't a difference of two squares. So what we need in order to write it in this structure is perfect squares. So we have 9, which is 3 times 3. X squared is x times x. And 16 is 4 times 4. We've got our minus sign to go in the middle. So that would put a 3x here. 3x times 3x would be our 9x squared. And a 4 here. 4 squared would be our 16. So we can do that. That means this is a difference of two squares. Now remember, what I have here is not my factors. This is just recognizing that it's a difference of two squares. So my factors will be two binomials, and those both binomials will both start with a 3x from the first parentheses. And the 4 from the second parentheses, one of our binomials will have a plus 4, and the other will have a minus 4. Two reasons. This creates conjugates, which is what we need. And second, remember that our second term is a negative 16, which means that we need one positive factor and one negative factor of our 16 to get that negative. So we should also check it, just like we did with trinomials, to make sure that we haven't made any mistakes. So here we have 3x times 3x, which is 9x squared. We have 3x times a negative 4, which is a negative 12x. 4 times 3x would be a positive 12x. 4 times negative 4 is a negative 16. So notice here, we have negative 12 plus positive 12. That would be 0. So this term goes away. And we're left with our 9x squared, which is the first term, so that's good. we're left with minus 16, which is our second term. So it checks, and that says, okay, this is our completely factored form of this binomial. All right, let's go on to another example. All right, so in this one again, we have 3x to the fourth minus 27x squared. So we want to look for our greatest common factor, GCF first. This time, both of our terms have x in them. So the smallest power of x, remember, will be part of our GCF. That's our x squared. Our numbers of 3 and 27 are both multiples of 3. So that means that 3 is also part of our GCF. So we've got 3x squared. So now, just like with trinomials, we are going to figure out what times our 3x squared equals each of these terms. So 3x squared times x squared would give us x to the fourth. The 2 plus 2 giving us the 4. And we need to know what times our 3x squared will give us negative 27x squared. We should realize that will be negative 9. So now we're going to factor out our 3x squared. And that will be times, in parentheses, what we have left, which is x squared minus 9. Now we go on to our second step, which is now to focus on the binomial x squared minus 9 to see if it is a difference of two squares and can be factored that way. So we're looking to see, can we write x squared minus 9 in the structure? A quantity squared minus a quantity squared. And so x squared would be x times x, so yep, that would be, and 9 is 3 times 3, so that would be 3 squared. And we have the minus again that goes with the middle, so we're good there. So yes, this is a difference of two squares. So again, this is not our factored form. This is going to create two binomials. And our GCF has to be in the front, just like with trinomials. So the x's will start our binomials. And our 3's will be our second term, but we again need one positive and one negative. This creates, again, conjugates, and also positive times negative is what gives us that negative 9. And again, checking just to make sure we have not made any mistakes. X times x is x squared. X times negative 3 is negative 3x. 3 times x is positive 3x. 3 times negative 3 is negative 9. Negative 3 plus positive 3 would be 0, so it's looking good. We've got x squared, which is our first term, and a minus 9, which is our second term. So this is our complete product of factors. All right, second example, or actually third, we're on the third example. All right, looking here, this one's going to be a little bit different. Here we have negative 2x squared plus 18x. This is the first time we're having actually a problem that starts with a negative coefficient. So we're going to handle this a little bit differently. Because we have a negative coefficient at the beginning, so we're starting with a negative number, that means that we are going to be factoring out a negative for our GCF. So we got to figure out what that is first and then make it negative. So again, both of our terms have x, so the smallest power, x to the first power, just x, is going to be part of our GCF. 2 and 18 are both even, and so they both have a factor of 2. So we might think, well, 2x is our GCF. But again, because our first number is negative, we are going to use negative 2x as our GCF. So now we have to figure out what times negative 2x will equal each of our terms. So negative 2x times x would be our negative 2x squared, x times x being our x squared. And then what times our negative 2x will equal positive 18x? We have to realize, well, that would actually be a negative 9. Because negative times negative is positive. So we are going to factor out the negative 2x as our GCF, and that will be times what's left, which would be the x minus 9. So now we go on to our second step, and we're examining now this x minus 9 in the parentheses to see if it is a difference of two squares. So we're looking to see, can we write it as a quantity squared minus a quantity squared? And you might be thinking, it looks good. We've got a minus. 9 is 3 times 3, so that's 3 squared. The problem, though, is right here. This is x to the first power. And we need x to the second power to create an x squared situation or a quantity squared. So this is actually not a difference of two squares. And what that tells us is that this is actually our complete factored form. That's all we can do. So we get negative 2x times x minus 9 as our answer. All right, moving on to our next example. So here we have x squared plus 36. So again, very first thing, GCF, greatest common factor. And so our second term of 36 has no x, so we don't have a common factor of the power of x. And the coefficient of x squared is 1, and the only factor of 1 is 1. So this time our GCF is 1. So now we go on to our second step. We're going to focus on our x squared plus 36 and see if it is a difference of two squares. So again, we're checking to see, can we write it as a quantity squared minus a quantity squared. And again, you might be thinking, looks pretty good. We've got x squared, so that's x times x, so we can put that x here. 36 is 6 times 6, so we can put that 6 here, 6 squared being 36. But the problem is the operation between. We have a plus in our problem, and we need a minus for a difference of two squares. The word difference is referring to subtraction as the operation, remember. So this actually does not work. So because it's not a difference of squares and our GCF is 1, that's telling us it has no other factors other than 1 and itself. So according to our instructions, that means it is prime, and that is what we will write. This binomial is prime. It has only two factors, 1 and itself. All right, let's take a look at another one. So here we have 5x squared plus 20. Again, beginning with our greatest common factor. So once again, our second term has no power of x, so no x's in our GCF. Our numbers are 5 and 20 though, and 5 and 20 are both multiples of 5, so that means that we have a common factor of 5. So our GCF is actually 5 here. So 5x squared would be our 5 times x squared. And 20 would be the 5 times 4. So we are going to now factor out our GCF of 5. And in our parentheses then we're going to have x squared, and the 4 is positive, so that's going to give us x squared plus 4. So now we go on to that second step, checking to see if x squared plus 4 is a difference of two squares. So again, we're looking, can we write it as a quantity squared minus a quantity squared? So x squared is x times x, so we can put x there. 4 is 2 times 2, so we could put a 2 there. But again, the problem is the sign or the operation between them. We need minus for a difference of two squares, and we don't have that. We have a plus. Now be careful here. You might be starting to think that we're going to say prime again, but we're not, because a prime has only two factors, 1 and itself. This actually has other factors. It has 5, it has x squared plus 4. So our correct answer is actually this, where we factored out our GCF. This is not a prime problem. It's only a problem where we can go just this far. So this would be our final answer. All right, so I think now that kind of covers all the possibilities we'll be seeing for binomials. We're going to do some practice problems. So you can pause the video here, give this practice problem a try, and I will reveal the answer in a moment. All right, so how did you do? GCF is 2, because 98 is an even number. 2 is prime, so 2 is their common factor. And then we get x squared minus 49 here, and that is a difference of two squares, because we have x times x. 49 is 7 times 7, and we have the minus we need. So we get two binomials, an x in the front of each of them, and 1 plus 7 and 1 minus 7 to create our conjugates with our GCF of 2 beginning it. All right, try this one. All right, so here hopefully you saw the GCF is 4x squared. 4 and 16, their greatest common factor is 4. X squared, smallest power of x, is part of our GCF. We get x squared, x minus 4 left over in our binomial, and that's not a difference of squares because we don't have x squared. All right, we're out of time here, so you can start your assignment.